Okay. Let me ask you questions, okay, to check whether you really understand it or not. Okay. Now, now, if I change my estimate model to be just one variables, n, okay? If my estimated model is just one variables, what happened? What will happen? Anybody? If I just have one variables n, but actually the correct model is this, what happened? Huh? I mean, this one will change, right? Then? So the role of the n is not only by itself. It also carries the indirect relationship from P and I. So the gamma 1 has its own beta 1 with all this relationship. Then what is the auxiliary regression I have to do in order to have this bias, to understand the bias? Huh? Excuse me? I and the oh, okay. All the auxiliary regression, it is from the one we have included in the model. So in this one, it's just only n. Then I have run another one called I, because this P and I are omitted variables. Now I omitted two. One is P, one is I. And so I have, let me use just this notation to show all the auxiliary regression, okay? So I have run two regressions. And we get this one, and using, so the bias will be alpha 1 and the beta 2, which is talking about the indirect relationship, okay? Plus this one. It's not good to use the same notation, okay? I'll use another one. Okay, maybe alpha, beta, gamma, omega 0, omega 1. Okay? So this will be omega 1 and beta 3. This is all hat. Okay, the bias become to this. This is all included in our class activity tomorrow, due next week. This one, okay? I'm not showing the example right now, but this one will be included, one part of the problems. So in the assignments, I will tell you the correct model. Then you have to run to the estimated model with 1 variables and with 2 variables. Okay, I'm also using 3 variables. Okay, and you run the first one using just 1 variable. The other one is using 2 variables, and calculate all this bias. This is called one of the specification criteria, bias. Then you can also see those t statistics to see whether it is important or not. So now I wanted to show you from the eViews, how do you do that to know whether it is omitted variable or it is important variables or redundant variables. Okay, how do I do that? You know, from using examples like this, none of them are redundant, right? It's all important. Okay, so if I run these regressions, for example, but you can see from any others, okay? If I run this regression, this is the correct model. I wanted to see whether P or whether I or both of them are redundant. Since if I use this one, I can check whether P is redundant or I is redundant or both of them are redundant. But from the output we have it here, you know, all of them are not redundant. Okay? Okay, if you have the computer with you and you, I like you to run the output like this one and follow the way I do it. Then you will remember how to go through the procedures to check it, okay? Do I have to wait for you? Or I can just go directly. The function here is from view. After you have the output, okay, after you have the output, look at the function view. Did you see that? View. Then choose the one with coefficient diagnostic. Did you see that? Coefficient diagnostic. Where is it? View and choose the coefficient of diagnostic. Did you see that? Huh? Where is it? Oh, coefficient diagnostic. Did you see that? This one. Coefficient diagnostic. Okay? After you choose coefficient diagnostic, there are many, many subfunctions. Okay? Look at the one with omitted variable test or redundant variable test. Did you see that? Then since I have the N and P and I wanted to show that whether there's any redundant variable. Okay? Redundant variable. Then I can say, you know, since I just have, if I run the regression with N only. If I run the regression with N only, I wanted to know P and I are redundant variable together. Understand what I'm saying here? So I tell, where is here? I will tell, and here say one or more test series to remove. Means, do I remove N or do I remove I or do I remove all of them? Okay, I can do this 3 ways, but I have to do it one by one. Okay? So if I wanted to check whether, since I just have N variables, so I wanted to see that whether P is redundant. So I use P. Okay? Then, okay. What did you see? What did you see? T statistic, right? And F statistic. Do you see that? And this T is showing, look at the expression on the top. Redundant variable test, equation Q1. This is what I have my full model. Okay, I name it Q1. Then simplification is using Y and MPI. I have the full 3 variables. Then redundant variable P. I'm checking whether P is a redundant variable or not. Okay, so look at the information. T statistic means if this P has T statistic. Did you see the degrees of freedom? 29. Why it is 29? Since my original have NPI, right? An intersection, and constant, and 33 observations. Therefore, the degrees of freedom is 29. Okay? Then this T statistic, the probability is important. Zero is very close to 0. Means what? This is not redundant variable. P is not redundant variable. And how about F test? It is the same. Okay, and the rest of them are the information about F test. Did you know what kind of test is this one? We learned it from chapter 5. Partial F. Partial F. Didn't I say that we will get to this partial F test in chapter 6 or in chapter 7 or in the future? This is just partial F test. So from this result, you know that P is not a redundant variable because the probability here is significant. Either you see T or F, the result will be the same. Okay? Then, let me go back to my original one. So now I wanted to check, I again. And okay. See? Again, the redundant variable, I'm checking I. And T statistic tell me, and F statistics all tell me that they are not redundant. They're important. I'm using alpha as a 5%. You can use this one, and after you run this output, then just copy up to these parts. Okay? Then copy, format it, then using the Word. Where's my Word? Paste it. Then you have your answer. Okay? Understand what I'm saying here? Okay. I'll put this one here. And then let me go back to my original one again. Then I can use the both. Okay, redundant variable. I wanted to know whether P and I. So I put the P and I, these 2 variables, and I hit OK. Now, since I'm working with 2 variables, therefore there's no t-test anymore. This is really partial f-test. You see the degrees of freedom, 2 and 29. Okay? And this F test also tell me that both of P and I are not redundant variables. Is that clear for all of you? So I can use this one here, and I'll just copy up to here. Copy, format it, and I'll go back to this one and continue, paste. So this one is checking with the I, this is one checking with P and I. All the result is here. Okay, this is from eViews. You don't have to calculate by yourself. Just using the programs. This, how fantasy to using the statistical packages. You don't have to calculate by yourself. So to know how to use the statistical package is also important. So that's why we learn in this class. So I hope we learn it from here, can help you to work on your dissertations or thesis. And what you learn from this semester is not enough. It's really not enough. Actually, just the half parts of this textbook. We have several chapters for the rest of this book, which is important for all of you if you want to do your thesis is related to finance, accounting, or some, really in business area. But if you're working with like human resources or marketing or something, maybe there are different stories. Okay, but especially for finance, you all need to learn the rest of the topic from this textbook. Otherwise, it's not enough.
How to copy this to Word?
Just copy. Just highlight it. Highlight from the beginning.
To end.
Highlight from the beginning. You don't have to copy all of them.
Oh, okay.
Highlight from here. Yeah, up to here. Okay. Then copy. Then okay. Then use the word. Then paste it.
Oh, okay.
Yeah.
Thank you.
Okay. All right. All right. Then I may also use, look at this one. Okay, this output. Okay. This one. Let me go back to the original one. Okay. Okay, like this one. I use the N and I only. I may check whether P is omitted variable. I can check whether P is omitted variable since I just have N and I, right? Okay, so again, I'm using the view, coefficient diagnostic. Now I'm checking with the omitted variable. So I choose P. Okay? Then hit OK. See what I have. So I can copy these parts and put it here. Okay, look at this one. This is called omitted variable test. And equation 2, which I have N and I. Okay, this is constant. Okay, then I'm checking whether I omitted variable P. Then this one tell me what? P is significant, right? The variable, so I really omitted the P. since this is telling me that P is important variables, so I omitted a P variable. This omitted variable test tell me that I really omitted.
Means that you should have put it in, right?
Right. You omitted a variable, right? Any questions so far? And this one is also one part of the t-test, or if you want to check both, then that's partial f-test. Okay, so this is also one of the criteria. You can use, the textbook just show t-test, but included in this criteria, we also can show the f-test if I wanted to test 2 or more variables. Okay? All right? Okay. And there's some other criteria. There's some other criteria which is on the appendix in chapter 6. I'd like to, all of you, turn to the page, section 6.7 on page 202. The author introduced 2 famous specification criteria. The first one is called Ramsey's test. Did you see that? Ramsey's regression specification error test, called RESET. Okay, I like to save this one until chapter 7 because most of from the theory parts of this test is really checking with functional form problems, so which is in the chapter 7. So I'll leave this one, I'll wait it until chapter 7. Okay, but I wanted to say something which shows on page 205, which is called Archaic Information Criterion and Bayesian's Information Criterion. You all see that? You all see that? Okay, and according to the author shows, okay, we do have some formulas to calculate what we say the archaic information criterion and Bayesian information criterion. Archaic information criterion is stand for AIC, and Bayesian information criterion is standard for BIC. Okay, and this AIC and BIC, we all have formulas go with it. Okay, but you don't have to calculate it by yourself. The EVIUS output do provide this information. Then where is the AIC? Did you see this archaic information criterion? Did you see that? Archaic information criterion. And there's one called Schwartz criterion. This is really BIC. Okay? And the EVIUS also provide another criterion called Hannon-Quinn criterion. Okay, so we can see this is really similar. This 3 is really similar. And this 2, we do have the formulas from our authors, the textbook. But, you don't have to do it by yourself. You can just look at output. Okay, and what is this criterion is for? This criterion is telling us which model is better. But if you want to do this 2 criterion, you need to have exactly the same y variables, but maybe your x variables are different. You see what I'm saying here? Just like we have this one. We have the model NPI. We also have the model without P, just N and I. And which model is better? So if we have this kind of criterion, it also tells us that which one is better. Okay? But we already know that based on the t-test, f-test, we know this one is better than this. Right? Because P variables are important variables. Okay? But can you tell from the AIC, BIC, and also the Hanna-Quinn criterion to choose the correct one? The answer is yes. Then how do we decide? Okay? Choosing the one with AIC or BIC or this Hanna-Quinn that lowers the number, the better. So look at this one, NPI is, if AIC is 22 something, but this one, AIC is 23 something. So this one is smaller. So this one is better. Okay? So this is popular criterion. Help us to choose the correct model. And you have to do this one from our assignment due next week. Okay? You just run the output and see the numbers. That's it. You don't have to do anything. Okay?
Madam, what is a good indicator of whether the three criteria are?
You mean which one?
Yeah, but they are pretty much the same, right?
Yeah, you can either one of them, but they give you the same answers. Look at
For instance, so you have
look at Schwartz BIC. This one is 22 something, right? What is this? 24 something. Which one is smaller? Again, this one.
the one that is smaller is the worst, right?
The one with the smallest one is the best. And these three criteria, really get to the same conclusion. But you don't compare, AIC with BIC. Never do that. Okay? You can compare the models with the same y variables but different x variables. This is the purpose for. If you have different y variables, do not use this criterion to do the comparison.
So if you want to do comparison, you want to do between the two.
I'm sorry. I should use this, compare this one with this one because my y's. This is the auxiliary regression. So I have to do this one, okay? So again, the AIC here is 22.12. This one is 22.64. So 22 with 0.12 is smaller than 22.65. Okay? And you have to do this one too in our assignments. This just read it from output for all this information for. If you don't use it, what for this output? All this output, you have to use all this information, right? Without knowing the important informations, then this output is useless. Yes.
Is it the smaller, the more accurate model?
It's the this better model. It's the better model. Okay. We don't. It's the better model. We don't always use the, the accurate or something, because all these models just to show the evidence of the theory. So we will never have the correct model. No, actually, I don't have to use the, this one. Nobody knows what's correct. Okay. Any questions so far? No? Okay. So this is, okay, since I'm always saying that we have this homework due next week, then why don't I show you the assignments? Okay? Let me show you the assignments. Where is it? Where's my assignment? I don't have it? Let me see. I don't have it? Is it this one? No. Oh. Let me get it. I thought I have it. Let me see. Well, I don't have it. Well, let me get it from iLearnings. Yes, I do have it. Fortunately, I do have it. Okay. Make it bigger. Let everybody understand it. Okay? I will give you the data file called child mortality. Okay? And these are the variable name, the definition of the variables. Okay, CM is what we call child mortality. It is the number of deaths of children under age 5 in a year per 1,000 live births, which is dependent variables. So this is dependent variables. Okay, and we have 3 independent variables. The first one is FLR. It means female literacy rate. Okay, what's the relationship with the female literacy rate with child mortality? Positive or negative? What's the female's literacy rate? What does that mean? This is the female with education, right? Right? So if the female with education, what's the child mortality rate? Child mortality rate means the death of the children. The child was born, right? So what does this mean? Usually, what does this mean? The better education, the less child mortality rate. Okay? No, I'm asking a priori means by expectation. What is the expected relationship between C and each of the variables? So, look at this one. I'm answering questions for all of you. How about per capita GNP? This is per capita GNP. Means if the higher GNP means the nation is wealthier, right? In that case, the child mortality rate will decrease, right? So this is negative relationship. This is negative relationship. How about this one? This is total fertility rate. What do you mean by fertility rate? Means the woman give birth, right? The more birth, the higher probability to have the mortality, right? So this is positive. I already answered A. Okay, B. This is the interesting parts for B, C, D. Look at this one. B. Regress CM on one independent variable and obtain the regression result. Understand what I wanted? I have 3 variables, right? So actually I have 3 models. C, regress CM on 2 independent variables and obtain the regression result. So I have 2 variables. Then how many do I have? Another 3. Right? I have 2 variables with this one with this one, this one with this one, this one with this one, then this one with this one. Okay? So complicated, right? So, I really mercy to all of you to make it, 6 options. Okay? A is using this is variable as the model. 1 variable model, and using this one is the 2 variables model, and actually this is the we say the correct model, 3, all of them. So this one for every option is same, but we will have different variables from B and C. Okay, now I'll give you the lots to draw which options you choose from your group. How cute is this box, right? Oh my. I'm working so hard. Okay? So you represent your group, okay? Choose one. Well, A, okay. Let me put it here. So, let me see. Where is my pen? Here. So your group will be A. So it's Rachel, Sachin, and Awin. Okay? Right? Then, okay, then your group, choose one. We have 8 groups, right? E, okay? Then E, let me write it down. E, this is E. Okay? Then, just give me, yeah, get me back. D, all right, so Harry, Junkai, and Steve will be D. Huh? F. Okay, Maribel, Vicky, Crystal, F. Give me back this one, okay? Then, I'll add Zoom to as the representative, okay? B. Okay, B. Give me back. Then there's only one left. This one. I think this is C, right? It should be C.
Yes.
Okay. All right, thank you. Then there's one group. Okay, choose one. F. Write it here. F. Max, choose one. C. All right, so we all done. Everybody knows your option, right? So if you work with the C, then when you work with the B problems, just run this regression. Okay? C, this regression models, and D, all of them. Okay? So look at this one. This is what we call BCD, right? Then, question number 2. If the regression D is the correct model, means three variables, just like we have it, this one. Okay? If the regression D is the correct model, but you estimate B or C, so you run one variable model or 2 variable model, what type of simplification error is committed? Document the consequences of this type of error. Show all the calculations. This is called biased, right? This is what you have to call. And this is what we have done all of it here this morning. Okay? Then, number 3. Suppose you estimate B or C. How would you decide if it is worth adding the other 1 or 2 variables to the model? What test would you use? Show the necessary work. So what would you do with this? Am I just telling you how to do it? You know, what test? Oh, I should put tests instead of test. Show everything. Oh. So there are many, right? What can you do? For example, what would you do? Using the 4 criteria, and except the theory, you know, that's just forget about theory. Okay, we already know the theory. Okay, so use the T or F, use the adjust the R square, and then bias. We have done it on the second one, right? And AIC, BIC, or Hannon-Quinn test. Anything else? I think that's it. All the criteria we learned today from the textbook. It's all in the textbook. Okay? So it's not difficult, right? Just do the practice. Then turn in next week. So is that clear? All right. Yes. Which one? Oh, okay. Table. Okay. Okay. The A means that, you know, since B parts, I'm asking regress CM on one independent variable. And it can be either one of them. So if you are in option A, just use this one. Do not use this one. Do not use this one. This is not your option. Okay? Then if I use two variables, then with this one, there's two possibilities to have two models. Means the rest of them, this one, since I have already, the first one is this, right? So I should have this begin with. Then the second one, you can choose PGMP or TFR. Okay? So this is the difference between A and B. Okay? Then D, since I included three variables, so all the options is the same. Means that we have the same correction model, correct model. But we do have two different estimated model. One is just with one variables. The other one is two variables. Okay? Clear? If I don't do this one, you have to do everything, right? That's too big. So just choose either one of them. It's, it's a lot enough. Okay? Okay. Then if you don't have any questions, then I will take a break again. Then later on, I'm going to discuss 6.3. This is a very good chapter, very good examples. I hope you will enjoy that example. Okay? All right. Let's take a break.